change in that means your structure is either under strain or the vehicle loading is higher. So it's monitoring or performance assessment is not really complicated business anymore. Technology is readily there. So time scale, putting everything into easily readable format. I use the word format, but it could be a asset management software. Anybody from asset management background? Anybody with the PWD or the local agencies here? Road transport?
Yeah.
Okay. So you might have, those who are familiar with that system, they might have a software system where everything is recorded and transferred, or they might have everything as a register, which is even more difficult unless you access the register to get any information. Okay, so that's that. So coming back to what I want us to do in the next few hours is to start thinking in a circular fashion, as well as design, as well as decide when you put a structure together, how these main aspects of the structure will influence your structure. It's easier for steel structures because you can see the steel corroding and you can take a quicker action on the steel as well. But depending on the nature of how the steel is put together, it might become difficult. For example, steel with a box section like that, column, quite often use a box section, a hollow core. You have no idea what's going on inside of it. That makes it really difficult to manage that asset, and you are relying on that thickness to carry the loading. Okay? So a designer might have a choice. Should I go for a box section or should I just go for a kind of section? Okay? Where things are open. But this may not be great for a torsion, open and closed channel section. So you need to decide that. You need to say, look, for torsion I need it to be closed, but I know it's going to be really difficult to maintain, so I'm going to close it completely from the top to bottom. That's your decision, right? You can have a column which is completely sealed, and you can even put a moisture sensor inside or have an inspection hole. So simple things like that can help you to maintain it in the future. And you need to transfer that information to the asset manager and say, you need to look at this. And if you see any weeping happening on that small inspection hole that you put in, you need to take an action. That information needs to be transferred. Okay? Okay, we'll leave it at that. So, all my watches are in the UK time. What time is it? The advantage of a smartphone is that it doesn't let you sync unless you have internet, which means the watch cannot be changed. Okay. But just very quickly, I'm going to introduce my team and the nature of work that I do. Because some of the discussions here after might lead into that. So, my team, which includes some of my seniors who I did my PhD with, Professor Bashir, some of you know them, and also my students thereafter. We look at developing new tests and new instruments for testing quality control of concrete. Most of it is focused on in situ quality control. Part of the reason is we know there's a difference between factory manufactured and in situ. The difference is the people involved, the difference is the exposure. In factory you have the control to control it, not on the site, you don't have it. So all of these are surface mounted or surface based instruments. We work a lot on, sorry, it's quite zoomed in slide, we work a lot on materials. What we're looking at is low impact material. We're going to be working on some of them. Geopolymer is suggested as a new thing. It's been there for hundreds of years. We believe it's been there for even longer than that. But the technology is becoming more adaptable now. We now have the technology to reverse engineer a lot of things. So we look at, for For example, if I say PFA, you're quite familiar with PFA? So if I say you can make a very solid, strong concrete out of just PFA and some chemicals, would you believe me? You guys are doing the work here anyways. Yes, you can, because all PFA needs is an activator. So if you add an activator, just an alkali silicate compound, you can make PFA as strong as cement. Portland cement, which you buy. Portland cement activates the PFA. So all you're doing is replacing that activator with a chemical activator. So we do a lot of work like that. It's all to see if we can reduce the impact of cement production. Cement production, what's the CO2 production? What's the CO2 produced per ton of cement? Let me rephrase the question, sorry, wrong. If you produce 1 ton of cement, how much CO2 will be the output? So you're saying 1 ton to 1 ton? I'll say 680 kilograms of CO2. 0.75 is norm now, almost norm within the UK. And they're saying so much so that they can go down to 680. 680 kilograms. Disputable, clearly, because they're burning a lot of other things to get to that 680. They buy the plastic waste, they burn it, and then they say it's sort of, and that's how they reduce to 680. But it is, you cannot dispute the fact that they brought it down from a ton, which you're familiar with, to 750 quite easily. That's just efficiency of the production itself. The cement industry has the capability to go further if they want them to. They have the capability. So it's a drive that's required, and the norms. And the environmental norms, as it changes, the cement industry will adapt it. I mean, they have more money and capability than all the universities put together. So they can change it, okay? They will, I'm sure they will change it in the future. So that's one part of the work. The other part of the work is we look at active structures, and then we test them out, and then we tell them what state your structure is, when can you expect a repair. Quite often, that's when you need to be repairing it now, because that's the reason they came to us. And that's one part of our work. So we do a lot of testing, and sometimes quite challenging testing. So here, a student of mine is actually in the sea. He's just standing there. It's fully buckled in, as well as there's a rope behind her with the safety harness and inflatable unit. Partially because that tide level can raise very fast, so we need to be on the hook to pull her back. She's about the strongest of the swimmers, so we have to let her go. So our team is quite mixed, and which is great. Some of the other work is in the building sector, because the largest emitters of CO2 other than concrete cement users are buildings. I was reading the stats for different reasons, so I'm going to ask you, this is a city very close to you, Mumbai city. If I say, can you tell me what is so Mumbai city's electricity usage per year? Use that as a pie chart. What is the largest user in the pie chart? Can you name it as a type of users? Or what do they use their electricity for in Mumbai per year? The use industrial use.
Also diesel.
Yes, but no.
Heating and cooling.
Who said heating and cooling? Does Mumbai need heating?
Cooling air conditioning.
Answer is yes. Mumbai does need heating. It depends on which aspect. If industrial guys might need a lot of heating. Cooling. 50% of electricity usage in Mumbai is used to cool buildings down. Imagine the population of Mumbai. And when you look at the electricity usage and you see that 50% is used just to cool the buildings down. Not to feed the population, it's to cool the buildings down. And that's the scale in which you're working. So you need to, so that's why most of our work will start to look at buildings. Our requirement is completely different. We need to heat the building. In winter, it's desperate. So we need to find a way of keeping the heat, minimum heat that we can put into the building. So much so that we pack layers and layers of insulation now into it. And those layers need to be kept very carefully. If you put everything into the building, then the building is going to sweat out. And it's really unhealthy for the people inside, so we have to put one layer of the structure here. So this is the inside, so you're here. We need to have some form of finish, because everybody likes their house to be finished. So this could be a structural layer, and there will be a layer of thick insulation here, and a deliberate layer of cavity, another layer of facade. Quite often it has a waterproof screen in front of it, and there may be, and very likely these days there'll be a vapor barrier here as well. So it's a very complicated construction, but it pays off. Our heating bills are just coming down every year. Okay. So it's that level of sophistication that we need to bring our structures to, and that's the other part that we look at. We look at the existing structures to see how do we pack this information in, because existing structures may only have these two on the outside. And the more changes you bring in, that means you're going to take the space away from people. So I'm going to retrofit this building, this room, which means I'm going to put insulation here, so your room space is now becoming narrower. You're not going to like that because it's going to affect your functionality. This will be easier to cool. It'll be much efficient for the air conditioners to cool the building down. But it's a give-off. So it's easier for new buildings to do it than for existing. So that's the other part of it. Anybody have any questions, feel free to ask me. Right. So the best way is when you go to the website, you can you will see technical guides as one of the tabs. So within the technical guides, all the information is organized under concrete, steel, and structures management. Okay. So if you take one, for example, if you look at cracks within concrete structure, it then shows you an Excel output of where the cracks can originate from, what reasons why the structure will crack, and then it connects to that information as well. So you can read the cracks page and it will tell you what are the reasons why a structure will crack. And if you click on any of the reasons, for example, thermal expansion or delayed intrinsic formation, when you go to that, it'll show you with picture and figures and all of it how this happens. So it's a very useful resource. We were able to put that together because we had a lot of contractors with us, and they had these structures with a lot of problems, and they knew the learning pathway because they just learned it themselves. And it's them who suggested us to put that in this fashion. When I have internet tomorrow or later today, I'll show you. I shouldn't come here now. So I'm happy to send this Word document to you. I'm happy to send the Word document to you. I'm sure we have the email access to all of them, right? Okay. Okay, good. So I'll send you some of the packages, some of the information, and then you can get access to it. Okay. So, how do you feel? Are you bored already, or you're just eager to learn, or you're... Can I just get a cross-section of you? How many of you are master's students? Okay. Are you working in concrete area, or are you working in structures? Concrete? 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 You're not a master's student, are you? Okay. Oh, we had to move. How many of you are doing PhD? Okay. Are all of you in concrete area, or are you in structures area, or a bit of both? Bit of both. Okay. Faculty? Faculty here or faculty outside? Very good. So, anybody else?
There are some professionals, working professionals.
Good, okay. So you can do your best to dispute me, and we'll try. The best way to learn is to recognize how much you know of already, okay? And the second part to know is how much does the other person know? Because a person who specializes in an area, be it a professor or be it a student, they would read quite a bit about that area, whether through Google or whether through literature. I would say Google is the first point of your learning, for anybody's learning. You start in Google and Wikipedia, oh, this is what it is. Then you get your keywords into your head and then you go and learn further. So coming back to the story, if you talk to that person, you get to know that topic quite well in their version very fast than you can learn yourself by reading. Am I right? So talk to each other. Absolutely. Learn from each other. That's why I asked what the cross-section is, because every one of you have one or more knowledge in different areas that we could bring together. And I'll try to pull it out of you every now and then. Makes my life much more easier standing here. But one good thing is all of you have a very eager young mind. That's one good thing of academia. We never age. Our mental age is always the same as an undergraduate student. That's what we see every time. That we kind of forget how old we are, because we see students who are quite eager, quite energetic. Okay. This is the UK's version of structures that have reported problems, obviously, and what problems did they report. So we looked at 100 structures that reported issues. 100 is an example. And within that we figured out how many of them have reported chlorides as an issue, how many of them reported carbonation as a primary issue, okay? There's a reason I said primary, because quite often you might have both, but one is more predominant than the other. It's very hard when you look at a very old structure to figure out what killed it. But as far as we know, in the UK, about 33% of our structures have chlorides as a primary issue. It's lower than anywhere else. The reason is we know chlorides are an issue in the UK. UK standards are very heavily geared towards chlorides because we know it's an issue. We're an island nation and we put a lot of salt, more salt than any other country in the world. Part of the reason is our climate is a bit awkward. So in the winter, say for example in Canada, in the winter the temperature goes down dramatically. Okay, so yes, you may get snow, which is you need to use a snow clearing device, but it doesn't freeze over. The surface glazing and freezing over doesn't happen. It happens initially, so you can salt it, it's fine, and then you can hold on to it until the winter is nearly over. Whereas in the UK, this kind of freezing happens on a daily basis. So every night towards the winter, you will see a salt vehicle coming in, sprinkling salt, rock salt, all over the roads. It's very corrosive. It's sodium chloride, but it's very corrosive. And then a few hours later, our fantastic weather, rain comes in, takes away all the salt, puts it very nicely on the structure, and then the roads are clean. But the water is there, which means the water will freeze over. So the second round of lorry has to come in the night. So this can happen 2-3 times in the night, every night. Even when you microscopically look at a couple of hours in the night, our temperature is not too far below zero, but it doesn't really go into the negatives, which means we just keep going up and down all the time. That's really bad. In terms of cycle of freeze thaw, we have many cycles of freeze thaw in a day than some of the coldest parts of the world. Okay, so UK is a very moderate climate. That word moderate is really hiding the problem. Okay, it's not moderate for the exposure. It's moderate for people, not for the exposure. So 17% is carbonation. It's an industrialized nation, so you can expect that. And you have corrosion due to chlorides.